So our next speaker is Kamesh Sambath, lead developer advocate at Snowflake. He will be sharing his thought about democratizing AI, diving into open source revolution and Snowflake, Arctic LLM, and much more. So I welcome him to the stage.
Good. Good afternoon. Sorry, I cannot see along because of the lights here. So 20, 25 minutes of Arctic blast. I'm not sure I can get an Arctic blast done in Kerala or anywhere in India, right? But I'll keep the session very light and weight. So I'm going to talk about how do we use Snowflake and its platform. I'll try to shift to a lot of demos and slides to make things interesting. And if you have any questions, we have a booth right outside opposite to this hall. Probably like I can take questions there, right? Also, I have my social handles here. In case if you have questions, you can connect me on LinkedIn, GitHub, wherever you want, and me post a question. I'm happy to answer your question as well, right? So I'll give a quick intro about what we do at Snowflake, and then probably I can start talking about showing demos. So one of the guiding principles of AI at Snowflake is these three things. So we say like we have easy, efficient. I'll just move to this side so that like I'm not blocking this. Easy, efficient, and trusted. When I say AI from Snowflake's perspective, it's AI for the enterprise. It's not AI for like what we do for ChatGPT, Claude, or other stuff where you just go query something, which is a very general purpose thing. But what we try to do at Snowflake is taking AI for querying enterprise data. How do we query enterprise data? To do that, the driving principles are easy, efficient, and trusted. I'll tell you why we say this. Because the developers, the moment they start with AI or ML, the first thing that comes to the mind is a little shaky thing, including me, like when I was starting to do this stuff. Because we know it's hard. There are a lot of things that I need to do, which makes it very difficult for me to implement immediately, test something, do POCs, and make my leaders efficient, right? So which is like make smarter decisions, like which causes an issue. So we made things super easy. We have REST APIs, we have low-code functions, and we have no-code interfaces, using which we can just get started with AI pretty easily. So you don't need to load any models. All models are loaded for you by Snowflake. It's like a managed service that we do. Top models are available for you to be used amongst like embedding or Arctic, LLMs, or even if you want to do document intelligence. We'll talk a little bit more in a second. Efficient, we did not load all the models that is available in the market right now. We choose some models, and we categorize them like large, medium, and small, depending upon the context window. And we chose the models to be available for you. So that's where we draw this efficiency. I'll show you a couple of graphs a little later. Trusted, everything within Snowflake is always trusted. What we mean by that is we don't share any of the data, the enterprise data that I'm going to use with LLM to any of the providers of the LLM. So all the data is going to be reside in you. You have the control of the data at your side. So that's what we're going to do. And then every data has to pass through what we call as a Snowflake horizon, where you have compliance, security, ACL, RBACs, everything put together, even your LLM data. Which means that if I have a P2 policy on my data table and I'm using LLM to query the data, the applicable P2 policy is still applicable and the response comes back. So that's what we do with trusting. So let's talk like why we make it easy. The very first thing is like we have things, as I said earlier, Snowflake horizon at the bottom, and then we have AI and ML separately. So we have Gen AI, what we call as Cortex, which is our kind of AI ecosystem of things. And we have app development studios, notebooks, and other stuff that are available for you to build applications quickly. I'll show you some Streamlit examples, but you can also do the same thing from Snowflake notebooks. The advantage of Snowflake notebook is pretty much a Jupyter notebook, but only thing is that you can also able to execute SQL in the Snowflake notebooks as well. So that's one advantage we get. I'll show a couple of examples where I use them. And then like we have the machine learning separately, but it stands the same stack. If you see the data Snowflake horizon, where we have also have a model registry and a feature store. So it will also allow you to store the models, version them like your source code, and kind of start taking them with you. So that's where we have the data and model governance in place. That's where we achieve the whole trusted thing, right? How do we make things easy? I'm going to talk to this, and then later I'll start to jump onto the demo so that like I can have some questions later. So at the foundation, we have all the models. We have task-specific models. What we mean by that is like if you want to do a complete, summarize, translate, sentiment analysis, and all these functions are readily available for you. You don't need to write any code. They're available in SQL, Python, or REST API. So whichever way you want to integrate your applications, you can start using them. We also have embedded models typically used in kind of RAG-based architectures, retrieval augmented and generation, where I want to build a knowledge base based on my existing documents, or my support team wants to talk to the data which is within my organization to get some information when handling customer support cases, for example. So those are there. So we have vectors. We don't need to go for a separate vector database within Snowflake, because Snowflake itself is a data warehouse plus database and everything put together. We have a specific vector column that you can use to store all these vector data, like what that you extract from the chunks. And then we have foundation models, the ones that I listed there. We have a flagship Snowflake Arctic model. I'll talk about that in a second. We have from NVIDIA, Meta, Mistral, and Reka, and even Gemma models are supported right now. So these models are loaded for you. You don't need to load the models. You have to just specify which model you want to use. I'll show an example again. For people who wants to chat with the data, I want to kind of in a plain English or vanilla English, if you want to chat with the data, then I can start to use two features called as Cortex Analyst, which will allow you to kind of query the data and get insights in plain English. You're not going to write any SQL queries. You're not going to write any Python queries. It's just going to be plain English. I can query my data and get the data out. Or if you want to search my documents, then I can go for Cortex Search, so which basically searches the document and retrieves the data out. For example, if you have tons of PDFs or knowledge-based portals where I extract the data, store them, vectorize and store them, and use RAG kind of do the search. In Cortex Search, we go a little extra. We also do a hybrid search. We combine keyword or lexical lookup plus semantic search put together. So those two things comes into Cortex Search as documents. And then we also have a studio. We call them as AI/ML Studio. Basically, that allows you to write all these things without writing a single piece of code. I can just do mouse clicks. And then kind of create a forecasting model or anomaly detection model or create a fine-tuning model. You can do everything with clicks. No need to write code. The stability of this whole Cortex API is such a good that we developed our own two applications, Copilot, used by SQL and API developers to write queries right within Snowflake. You don't need to go out to write queries. You can ask it to write query. It will write query and give you. Even it can optimize query, do all other stuff the standard API or SQL developer will do. And lastly, we have Document AI, which basically extracts documents and kind of show this stuff, right? So what I'll do is I quickly shift to the demos, and then probably, if I have time, I kind of come back to the slides, and then I can walk you through the slides as well. But before that, I want to share this efficiency side of this. So this is Arctic LLM. It's a completely open source. Snowflake Arctic LLM is an open source model that is available in Hugging Face today. You can straight away use them. If you see this here, it has the best cost to performance ratio. So when it comes to enterprise, cost is very important. At the same time, I don't want to compromise on the output that it generates, because the moment I start to use experts, the cost will definitely increase because the compute is required. So you don't need to worry about all those things. We take care of that. But what Snowflake did is we brought in the right optimization so that your experts are efficient at the minimal uses of your compute resources. That's where it stands the best performance to cost ratio. And we have Arctic Embed. It's kind of like if you see the other models that is right now there, even other more models are added. It gives you the best performance here. You find out kind of like the leading performance at 1/4 of the size. For example, if you see Gecko, it's kind of like 1,200 million parameters. Right now, we just did it with 334, achieving the same performance that you see on the screen. So, which is again, this is used for extracting vectors from chunks, right? Your text or any other document. And lastly, we also have a document intelligence model built, which can read documents, PDFs, and other stuff. It's kind of, again, it gives you the best performance to parameter, because like we used 0.8 billion parameters compared to the other ones right now we have. So all these falls under Arctic family. We can see more information at docs.snowflake.com, where you can have more details about what these models will do. Okay. Lastly, we have data protection. That's a core. Security is the most important thing at Snowflake. So we don't allow your data. Since we are dealing with enterprise data, security comes first, then other things. Like what are the other fancy features we can give to you? Your data never leaves Snowflake, right? Whatever you're doing, even if you're querying using LLM, the data is going to be reside in your control. It is not shared with the providers. We don't use the data to train the models, or we don't do the commingling of data as well, which means that the data governance is very strict at Snowflake. Again, you can use role-based access controls. Calling these LLM functions is not going to compromise your airbags or ACLs and other things that you have in place. They're always going to follow these things. Content safety, it's the most important stuff that we had using Cortex Guard. Meaning to say, like, I don't want my LLMs to return some harmful content. For example, let's say, how do I make a bomb? I don't want it to say, how do I make a bomb? So I can put a guardrail there saying that you should not respond to all these kind of questions. So this is where we make it trusted. Efficiency comes from the models we use. Easy gives you the unified platform that we have to make things easier for you, right? So let me go back to the last thing. So you'll see the use cases. I'll jump into demos rather than running through the slides. I'll also share the slides to the organizers so that you can have a look at it. But let me jump to the demo to show you what I mean by all these things. So Cortex Analyst, as I said, let me see if this is active. Yeah, it is active. So what we basically do is we kind of use an LLM model. Let me go find out an LLM model for you. Semantic model, Snowworks, yeah, demos. With GenAI, and then I have this thing right here. Let me blow this up. So this is a semantic model that I basically created out of my data. Usually the semantic model is created by business users. Developers usually don't create this. I say which is the database I'm going to use, what schema. For example, in this case, I'm using support tickets as an example. I'm going to use support tickets to extract the data. I give some dimensions, the columns basically that I need to query on. Give some synonyms, what all other names this column is known for, so that the semantic search returns you the right value. And also some sample values about this. Similarly for customer name and other stuff. So this is analysis basically for business users to query the data against this. So I load this this particular semantic model to my to my query, analyst query, which is going to be a REST API call. I'm just using Streamlit here to this whole thing is built using Streamlit, which allows you to build stuff in pretty quickly, right? Let's say I want to ask a question. Say I want to break down my customer support tickets. Before that, let me show you the customer support tickets for a second. So this is the customer support tickets I have. So I have bunch of 150 plus 100 data here, different service types like cellular, business internet, and all other stuff. I have contact preferences. I'll come back to using this. This is simpler data that I'm going to use for my demo. If I go back here and ask analysts, can you show me a breakdown of cellular versus business internet? This is a question that your business user will typically ask, right? For example, I'm not doing any SQL query or anything here. I'm just asking this to give me a data. That's this stuff. OK, very good. So I got this data back. Let me reload. I'm running using my hotspot. So hopefully it works again. OK, let's do it once more. OK, ask this question here. Hopefully it doesn't have a block. I hope it's come back. Well, let's see. OK, there we go. So right now I got this query. I asked you to break down my thing in vanilla plain English. Your business users are using plain English to do this stuff. Breakdown, it gave you the breakdown of the service type, business internet, cellular, number of tickets we have, 34 and 114. The good thing about this is that it also generates you a visualization of this whole data. We are also getting more complex things added to this down the lane. And another good thing is it also gives you a SQL query that is getting generated here. What SQL query runs behind the scene to actually generate this whole data for you. So let me ask one more question, probably I do the unique number of cellular customers who are having this thing. I'm just going to do the same query again. So the power, what comes here is that your business users now can draw insights. They don't need to depend upon anything. I can make a self-service app like this and give it to them, and they can start querying the data that is there and then derive all those insights that they want. For example, in this case, I'm trying to find out service type as cellular, having email as a contact preference. I got 58 unique customers. Again, I got this SQL query generated for you. This allows you to give it to your app developers or anybody else to draw more insights into it. And the other one which also makes things interesting is that I told about Cortex search. For example, I've loaded a bunch of documents here to this particular search, and I'm let me open a sample document and tell you what data I'm going to look in for. So this data is already loaded inside. So if you see this one, I'm assume that this particular guy is on a phone and asking you for a query, right, to a customer support guy asking something about his invoice or something in the previous thing. Right now, the invoice, the support guys don't need to sit down and go search systems, make the customer wait on the phone. So rather, what I did is I went ahead and built a simple application, again using Streamlit. And then all these documents are already loaded into my database using chunks, using RAG, retrieval augmented generation. So all I do here is I just go query this stuff. Let's say, for example, what kind of service that Gregory has. This is something the chatbot, your customer service person basically use. Let me go start this one. Give it a few seconds. So I'm going to ask this customer guy, customer support guy is going to, while the customer is on phone, you see how fast the response gets back here. It says he has a service line 2 plan. This is what he has. And then I'm going to go back and ask another question saying, was he charged the international roaming fee? That was his query with the customer support guy. Again, it's going to come back saying, okay, he was charged $85 roaming fee. Go here. This is what here. So I'm kind of extracting the whole information. So this is how you do, like your customer support guy can now become more efficient, handling more customer queries in shorter time, right? Even your customers will be happy on this. Apart from these ones, so we also have a set of LLM functions, what we call as, so which is like, as I said earlier, there are both SQL and you have Python variants of it. I'm going to show you the SQL variants of it. For example, I have this particular support tickets data on which I'm going to do all the other query demonstrations here. One thing I want to do, I have a service type as cellular, business internet, and home internet. What I'm going to do right now is like I'm just going to classify these ones here. I think probably I shifted the thing here to the same notebook. Probably I'll need to go to a different one. LLM functions, sorry, I was on a different notebook right here. So let me start this. So this is what I was telling you about Snowflake notebooks. I can execute Python code, Markdown code, like what you do in other Jupyter notebooks. Plus, we also added a facility to kind of execute SQL queries here. For example, I'm executing the same SQL query what you saw the other one. So I want to do a classification of cellular, internet, and other stuff that we have right now on my requests, on my support tickets. So what I basically do is like there is a function, SQL function called as classified text. So this function basically takes a text. I want to use this text that is there in my request. Let me draw this on this request here, and then classify my data whether it's going to be internet or phone. Right? That's what the classification I want to do. So these are the two classifications that I have. And then I'm taking this text and then using this snowflake.cortex.classified text. This is the low-code function. We written all the logic behind the scenes. All you have to supply is like, how do you call a function, right? I'm calling a text and classes and extracting label out of it. So I'm just going to get a response back saying, okay, taking all these tickets, I'm just doing limit 5, just at the interest of time. And then it will say you like what is the particular ticket is classified as, whether it's internet or phone, right? For example, I travel to Japan. $90 international fees, data usage. It kind of goes that semantic search on it and kind of classify this. This is going to be a phone usage, right? You can do similar things for other stuff that you already have. And then there's going to be the complete function. This is where I said these are the currently supported models. Gemma 7B, JAMA is something which you had it right now. We have Llama 3.1, 3.1450B as well, the latest model that they had. We have Reka Core Flash. We kind of classified them as large, medium, and small, depending upon the size, the context window size, so that like you can use the one right now. For example, the same tickets request which I said earlier, the same one I'm kind of running this one to kind of find out like how fast, kind of make those things a summary or a bullet points. I give it to Snowflake Cortex complete function. It takes the parameter. This is what I was saying. You don't need to load any models, start any things for you. All you have to give is one of the supported model names. Like the model names, the one I listed here. In this case, I'm using Snowflake Arctic, which is an instruct model. And then I'm kind of using the normal SQL query to kind of go call this call. And then it gives me a text. And then it kind of gives you the summary as well. So I'll use the next cell to kind of do it a little neatly. So this is a text. And the output basically is what it does is like it just distributed it, because that's my prompt that I gave for this, saying can you summarize this request in bullet points, the one that comes in between these two things. This is a prompt I'm writing for it to kind of make the summary for me, right? So that's what I did here. And then I use, as I said earlier, so the advantage of Snowflake Notebook is also that I can take the data from the previous execution and kind of convert it to data frames or pandas or whatever you want to data frame, kind of to do that in plotting, right? Any Python tools that can plot this data, visualize this data, or do other thing with this. So I can kind of take in data and kind of start using it. So the other important thing we always do, at least with the customer support ticket case, is you want to analyze the sentiment of those customers. So we already have a sentiment analysis function available for us. It basically returns you a number between -1 to +1, -1 being negative, +1 being positive, and 0 being neutral. And the value like can take a round of it. I'm running the same stuff here. trying to understand the sentiment of the customers on the request. You see that it gives me back these values. I just rounded it off so that like it gives me 0 to -1. And then I kind of just did a little beautification of this data saying, okay, what does the customer sentiment looks like? For example, this one, like it says like is kind of neutral here with this one. And probably there is an international charging fee. There is please refund this amount. This looks like the customer is not happy, which is kind of a negative sentiment. And then there is a customer like who had these 7 days, blah, blah, blah. He's having something like a very happy customer, right? So I can derive the sentiment analysis that is done with this, kind of go and do all the sentiment that's required. Again, a function that is available out of the box. I can do summarize. If you have a huge text to summarize, I think I'm just using a smaller example here. This example is like 5-6 lines of text. I kind of got a summary like within 3 lines. So you can use the summary kind of thing to kind of go summarize a whole big text into smaller chunks. Is again a very useful stuff that we use task specific. And lastly here, I'm also using a prompt, right? This is a very basic guidance that we give to LLMs on what data we want to extract. So I'm giving a prompt here saying summarize this request in less than 200 words. I'm also trying to extract the data from it, right? The fees, request, and country in JSON format. So I'm kind of saying you like what data I need to extract from it, and then what format it needs to be returned to. And then I'm doing a similar select query here, request Cortex complete, giving the model that I want. I'm putting in the whole stuff here. I'm in the prompt. I'm just concatenating the stuff and then kind of giving the request here. So this will come back and say me, okay, this is what the summary is, and then let me plot the data again to make it look neater. So this is the thing. I traveled to Japan, the same one which I did in the earlier one. So on the response, what it basically did is like it extracted the fees. It was able to go do a semantic search on the text, extract the fees, extract the request, and then the country in which I was stuck. Because all this information is available for me on these things. So I just use the extract answer to kind of complete function to kind of do this stuff. In fact, I can also go do translation. We don't have support all the languages right now. These are the list of languages that is supported. A very limited list. We are expanding that. I can also go do a translation here, translate the request. Right now, if you see everything, I'm working on an enterprise data. So all my queries going and running on a table that I have within my database. It's not going outside doing stuff, right? Which means that all the data is right now is played with enterprise context. So in this case, the same thing I did, I kind of translated this particular text that I'm going here into French. Again, there are other things that we can do with this as well. I can also go back, let's say I have this text, I want to next answer a question from this text. For example, I want to understand how much you was charged, $90 fee or whatever it is, right? I can do the same thing, select a request, extract answer from the request. How much roaming fees was charged? I want to find out this answer quickly. I can just query this one to kind of do the same thing. I'm just kind of limiting first three rows. So this knows there was a $90 fee charge, so it just goes and asks a natural language question, and then comes back with a roaming fee here, right? Saying what the roaming fees was charged. So these are the other ones which you can do. I'll also talk about a document AI in a second. So before that, what we also showed to you is that, as I said earlier, this is no site. Like if you want to have a trial account, please do meet me in the thing. I have a $400 credit to give away. I can give away, you can just try out all these features in Snowflake. So this is the one which I was saying. I can also build my own search service on my data and make it available for people to consume. And then I can also fine tune a model. So let me see if I have a time, I'll do a fine tuning. I just have 6 minutes more. I can build a forecasting and anomaly detection and classification model, just click of buttons. I don't need to write a code for all these things. All it requires is a data set available for it, and I point to the data set just using clicks. For example, if you want to create a fine-tuning model, let's say I want to take it MISTL 7B, I use a database, let me call this my database, and then a schema that I want to use, some model name, demo 23, and then I just keep clicking, right? I choose a data set for training, and then I choose a data set for what should be my prompt, and then I choose from the data set what should be my response looks like, and then what should be my evaluation data set or inference data set, and then finally click start training. This is going to train the model, like fine tune the model. So let's not do that, but I was trying to show you how this no code interfaces looks like. So all it requires is just takes you through wizard mode to kind of do this stuff so that you don't even need to write a single piece of code to do anomaly detection or forecasting or classification. We are adding more functions to it. This Cortex search service is again a service that you can build on your data and expose it outside, right? So let me go back to see if I have covered everything here. I think we talked about analyst. We talked about, so where we use these two things. Let me take a tab on time. So these are the two different use cases. I'll share the slides anyways, so that you can take a look at them at leisure. We saw this demo conversation. So this is something which I want to expand, like RAG, how that RAG basically works. So we take a data, any data that gets ingested into a table, and then what we do is like we use Snowflake Python is nothing but the set of Python packages that we are available for you. It's again open source one. You write an UDF, Python UDF to extract the chunk, the data, the text from this particular documents or tables or whatever it is. And then we convert them into vectors and store the vectors in the tables. Like since Snowflake has a database and a table, we have a vector column which has dimensions like 384, 768, 1024. It's again any number of array, the two floating point array that you can store here. Whenever you ask a question like what we did on our demo, it basically kinds of converts the question into vector and do a semantic search on top of the data and get the number of relevant documents, and those documents get injected into your prompt. So that's a natural way of doing stuff. So what we have done in Snowflake is also, apart from semantic lookup, so we also did a keyword or lexical lookup where we kind of do these two things, take the results, do a fusion on reordering, and give you those key results, which means that your search is going to be even more effective than just doing a semantic search, right? So we saw that, we saw about the LLM functions. I talked to you about this, LLM functions. Document AI allows you to kind of basically extract data from documents. Let's say I have a PDF document, I want to extract data from PDF document using natural language queries. So for example, in this same thing which you saw earlier, let's say I want to extract the invoice number, PO number, or all these international roaming fee, etc., etc. I can using LLM functions. Again, this is going to be a click-based ones where I can create a model and kind of do this. So document AI is again, I can have a demo since I'm running out of time. If people are interested, pop onto the booth. I can show you the demo like how do we do with document AI as well. And then fine-tuning, I just showed you about fine-tuning. There's a little advanced concept, so probably that we'll talk about. I want to touch upon security and governance before I take questions. We do two governance in this, securing GenAI, Snowflake's governance commitment, full data secure, fully secure data, no training on your data, no request to third-party services, which means that we don't transfer your data to third-party services and then kind of take the response and mingle. Nothing is done. No co-mingling of data, which means that we don't use your data or some other customer's data to do this stuff. And fine-grained access control, this is more towards model and feature governance. Guardrails, I'll show you an example of how do we use guardrails. Models runs inside Snowflake perimeter. What I mean by that is that your data doesn't go out of Snowflake. So whatever your account is there, your AI, your data, your control. So we don't take anything on this. And then protected model IP, which means that you don't use the data to kind of train our own stuff. All right? This is an example of Snowflake Guard. We saw the complete function. The complete function also takes an array where I can give a role, context, and other stuff that we'll typically do in a prompt. It takes an object of parameters, right? One of the objects of like your temperature, seeding, and other thing that you want to give. One of those parameters is guardrails. When you make it true, then any harmful content will be automatically filtered by this complete function. So this is applicable to all those functions. The other good thing about Snowflake is that like all the responses returns you a JSON response along with the score. Mean to say like you can kind of go take the, if you're integrating with an application, you can make sure that which score is better to kind of go and do this. The score is typically between 0 and 1. Right? I think that's pretty much I have. I have a minute and a half to take questions. I'll share these slides with you along with the demonstrations. The code is also available publicly as well. I'll share those things. If you have any questions, I can take questions, or also I can also be available at my booth. Like probably you can just pop those questions there as well. Questions? Silence? Silence is two things, right? So probably I talk too much, like which it's going beyond, you overwhelmed with that. Otherwise, like, you do not understand. We're talking all the rubbish for the last 20, 25 minutes. I did not understand anything. So it could be two things which you can take, right? Great. If you don't have questions, like if you have questions, definitely please do pop out to our booth there. With that, I can probably give a minute back to you. Yeah.
Yeah, every minute is precious. So thank you. So yeah, again, a huge round of applause for Katnish, guys. I'm personally very excited with anything that comes with LLMs. So yeah, I invite our team to
give a token of gratitude to Karnish.